Hello, people watching this in the future. So at the end of class, there was a question asked about a topic, and I thought it was a topic we had gone over, but it was actually just a very similarly named topic. So I'm going to post this video where I talk about this topic using trigonometry to find lengths in a figure involving two right triangles, not the word problem version. So in this one, you're trying to find lengths W, X, Y, and Z using this figure here, and you're told that X times Y is 64. I've not done this problem before, so we're just going to see where it goes, see where it takes us. I'm going to start by focusing my energy in on one of these triangles. I know the most information about this triangle because it gives me an angle and a side. So I'm going to take this triangle over here, and we're going to see what we can do with it. We know that this is 39 degrees. We know this is 14, and we know this is W. So if I'm looking to find the missing, or looking to find W, I do need to find X as well, but looking to find W, I can do that. I know that W is the opposite side. I know that 14 is the hypotenuse. Opposite and hypotenuse, that's going to be sine. So sine of 39 degrees is equal to opposite W over hypotenuse 14. That means W is equal to 14 sine of 39 degrees. For those of you watching this in the future, I talk about how we do the math to get from here to here in the lecture video. So if that confuses you, please go back and watch the lecture video. So W is equal to 14 sine of 39 degrees. That'll give us one of the values we need, 14 sine 39. And that one is 8.8. All right, so we have W. The best we can do to find this other side length here is use the Pythagorean theorem. So this is 8.8. This missing side over here should be the square root of 14 squared minus 8.8 squared. I'm going to assume that they're going to be very lax on my, I'm assuming they're going to be very lax on the rounding here because it's telling me to round. So hopefully this doesn't mess up my numbers. 14 squared minus 8.8 squared. That's giving me a side length of 10.9. So I use the Pythagorean theorem to find this side length here, which is X. Alternatively, instead of using the Pythagorean theorem, I guess what I could have done, maybe I should have done that. That's what I should have done. This is what you get for getting a raw video of me doing a problem for the first time. Instead of using the Pythagorean theorem, I really should have just set up my triangle and used SOHCAHTOA because this is an adjacent side. So the adjacent side is X. We have an adjacent and a hypotenuse. Adjacent with hypotenuse gives us cosine. So we have cosine of 39 degrees is equal to adjacent X over hypotenuse, 14. So X is equal to cosine of 14 cosine of 39 degrees. Which indeed does give me a different answer. Huh. What answer did I get before? Maybe it doesn't. Did I get 10.9? Is that what I got before? I don't know. The answer is 10.9. All right, I have X, I have W. We need to find Y and Z. And if I didn't have any more information, if I had forgotten about this important fact, I'd be done. There'd be nothing else I can do. Oh, it was 10.9 before. So it was 10.9. So either way, you got 10.9, Pythagorean theorem, or setting it up like this, you would get 10.9 for X. So X is 10.9. This important piece of information is everything to us. So we need to find y. Well, look, xy is 64. X times y is 64. And I know that x is 10.9. So 10.9y is equal to 64. I'm getting that information, by the way, from there. So x is 10.9. Divide both sides by 10.9, and you'll get y is equal to 64 divided by 10.9. And that's not 58, 5.9. But excitingly enough, with this triangle, we know that this entire length here is x plus y. So 10.9 plus 5.9. This entire side is 16.8. And this side over here is 25, based on the picture. If we need to find z, which is the hypotenuse here, we can just use the Pythagorean theorem. This is going to be the square root of 25 squared plus 16.8 squared. And that gives me 30.1 for z. Now, if I'm lucky, I'll be able to screen over and see if these are correct. I'm going to pause the recording for a moment. So I just plugged those in and they are correct. So no rounding errors or anything. So that's how that problem was done. So I'll post this in a video. Obviously, you'll know that because you're watching it right now. Okay, bye for the recording.